So let's take a look here at the pretest. We're going to take a test on just 1.8 here before we move on to solving some trig equations. So solve the following right triangle. So when you're doing this, the first thing that you should do is that you should create your right triangle. I don't care how you draw the triangle in, but you need to at some point draw it in. So the information that we have here is that this is angle C. That's the 90-degree angle. I have A is equal to 23 degrees over here, and angle B is the first angle that I'm actually going to be able to find here. So I'm going to fill in that A is 23 degrees. Opposite of angle A is angle B is side B. And they tell me that that's 14. So I've got side B is 14. I don't know what side A is, and I don't know what side C is. So I'm going to find all that information. My angle B, the first thing that I'm going to find is that I know that in a triangle there's 180 degrees. So I'm going to subtract the other two angles. So I get 180 minus 90, which is 90, and then 90 minus 23, which is 67 degree angle. I get that B is equal to 67 degrees. So that's the first part. Then the second part is that I'm going to find either A or C. It ultimately doesn't matter. I have an angle here of 23 degrees. And so if I take that 23 degrees and I look at the A that's opposite that, I can use that and the information that they gave me of B equals 14. And I can use the tangent of 23 is equal to my opposite side A over my adjacent side, which was B, which is 14, and then just solve that. So I multiply by 14 on both sides, and I end up with side length A of 5.94, and we'll just round to hundredths here. I think as you go through the worksheet, they're all on tenths, but that's okay. A is equal to 5.94. So then C is my hypotenuse, so I'm either going to need to use sine or cosine. Because I created this A value here, I'm not going to use the A side. I'm going to use the side that they gave me because I can guarantee that the side they gave me is the length that I want. I might have screwed something up when I was going through. Maybe my calculator was in radians instead of degrees, or I might have had something wrong with the A value of 5.94. Okay? I didn't, but there's a chance that I might have. And so I actually want to use the fact that I have the adjacent side here and the hypotenuse, and so I'm going to use my cosine of 23 is equal to the adjacent over the hypotenuse. Okay, it's just going to help me out to make sure that that my numbers come out to be correct here. So I'm going to multiply by C on both sides. So I get C times cosine of 23 equals 14. I have to divide by cosine of 23. And I get that C is equal to 14 divided by the cosine of 23, which is 15.21 rounded. And now I have all 6 of the parts that I needed to in order to solve the triangle. Part B, we're doing the same thing. The idea is that I want to draw a triangle in here. I've got angle A, angle B, and angle C. Angle C is 90 degrees. They gave that to me. Opposite angle A is side A, which is 4. Opposite angle B is side B, which is 5.6. And opposite angle C is side C. I don't really have any other information in here in terms of angles that I really want to use. I could go through and I could use a trig function to find C, but because they gave me A is equal to 4, I can use the Pythagorean theorem with B equal to 5.6 to get my C squared. So I get 4 squared, which is 16, plus 5.6 squared, which is 31.36. Add those together. Take the square root of both sides, and I can end up with my C value here. of 6.88. So I end up with C being 6.88. They gave me the fact that that A was 4 and that B was 5.6. So those parts of this solving process are also done in this triangle. Now I have to go through and I have to find the angles. That's what makes this section different. If I need to find angle B, I'm going to have angle B here that I'm looking for. I have some information from angle B. I have the opposite and I have the adjacent. So I can say that the tangent of angle B is equal to 5.6 over 4. And when I do this problem, what I want to do is I want to take the inverse tangent of this side because I want to get the tangent away from the B. And so the way that I do that is I take its inverse operation. And so I need to do tangent inverse of 5.6 divided by 4 here. And so I get angle B is actually equal to the tangent inverse of 5.6 divided by 4, which is 54.46 degrees. So angle B is 54.46 degrees. I could go and I could use another trig function with A, and I could do the tangent inverse with A being the with tangent being opposite, which is 4 divided by 5.6. Part of the problem with doing that is that I get that if I chose to do that, I'd get that A is equal to 35.53. And so, but I guess actually if I rounded correctly, I'd get 35.56. And if I took that 35.56 and I added it to the 54.46, I actually get 90.02 for my angle A plus B. It can't be 0.02. It has to be a total of 90 degrees. And so when I look at this, oh, this is 0.54. That's my problem. I didn't round right. There we go. When I add those two together now, it gives me a 90 degrees. And so if you want to use that idea that the two of those angles added together have to give you 90, or you could go through and you could go through to guarantee that they're going to be come out to be the angle that you want it to be. You can take the same idea that we started with in problem A and do 180 minus 90 minus 54.46, and then by subtracting 90 and subtracting 54.46, you get that angle A would end up being 35.54 degrees. And those two things added together have to be 90. These three things added together have to be 180. Okay, one of them is already 90, and so the other two have to be 90 as well. The word problems draw some pictures. A kite is being flown at an angle of 75 degrees. So I've got an angle here of 75 degrees, a nice little kite up here. And it's 230 feet of string, 230 feet of string is let out. The question is, how high is the kite? So I want to know this value. Well, when I look at that, I've got an opposite and a hypotenuse, and so that reminds me of sine. So sine of 75 equals x over 230. Multiply by 230 on both sides, and I get 230 times sine of 75 is equal to 222.16 feet. That's how high the kite is. Number 3, we've got a 10-foot ladder that's 6 feet from the base of the house. So I've got a little house over here. I've got a ladder that's 6 feet away, and 6 feet from the bottom. Now the question is, how far, or what is the angle of inclination formed between the ground and the ladder? When I put the ladder in here, I've got a 10-foot ladder, and I'm looking for this. And again, if you put x there, that's fine. Just because I'm dealing with an angle, I'm going to put theta there, just because that's what I do. So let me fix my triangle here, and then we can continue with the problem. Okay, so there we go. Things that we have from this this angle, we have the adjacent side and we have the hypotenuse. So that reminds me of cosine. So cosine of theta is equal to adjacent over hypotenuse. In order to get rid of the cosine, I need to do the cosine inverse. Cosine inverse of both sides. Cosines are going to cancel out with the inverse on the left. And then I do cosine inverse of 6 divided by 10, which gives me 53.13 degrees for my angle of inclination. Then number 4, this is very similar to a couple problems in your homework and the problem from your note sheet. We've got a lighthouse. Go ahead and draw the lighthouse in for yourself. The lighthouse sees 2 boats. So here's the lighthouse. The lighthouse sees 2 boats. One's out here at an angle of decline of 5%. Oops, 5%, not 50%. The other one at an angle of decline of 8.5%. And so the angle of decline is going to be from if I were looking straight out. So if I were looking straight out here, an angle of decline of 5% would be here. And an angle of decline, I don't know why I want to keep writing 50%, or 5 degrees, but would be here. An angle of decline of 8.5 degrees would be somewhere in here. That is a horrible, horrible drawing. But hopefully you can see our two triangles in there, the one in blue and the one in green. So let's take out these 2 triangles and take a little bit better look at them. So I've got the triangle that looks like this, where this angle is 5 degrees. Here's my 90-degree angle. I had some other information about the lighthouse here, and the lighthouse was 50 feet tall. And so this actually would represent the lighthouse on the right-hand side here, because if I'm looking straight ahead, that lighthouse distance off the ground is going to be the same in both places. So I've got 50 feet with a 5-degree angle. I want to know how far away the boat is from the lighthouse. Then the second triangle looks like this. This is still 50 feet because it's representing the lighthouse, but this is 8.5 degrees here. And I want to know what's up here, okay? How far away is the boat? So now I have an opposite and an adjacent in this triangle, so both of these I'm going to use tangent. I'm going to multiply by y on both sides. So the y's cancel out. And then I'm going to divide by the tangent of 8.5. So y times tangent of 8.5 equals 50 divided by the tangent of 8.5. And I'm going to end up with y is equal to 50 divided by the tangent of 8.5, which is 334.56 feet. I'm going to do the same exact work over here, except I'm doing the tangent of 5 is equal to 50 over x, multiply by x, divide by tangent of 5 degrees, and I get 50 divided by the tangent of 5 degrees keep on making that 50. Gives me 571.50 feet. And the question is, not either one of those answers. The question is, how far apart are other boats? So the boats, if one boat is at 334 feet away and one boat is 571 feet away, I just have to subtract those things to get that the boats are 236.94 feet apart. Okay, so go through, draw the picture, use the angles in the picture, and then actually make sure that you're answering the question at the end of what the work that you've done.